Hello and welcome to my developer interview series, number 11, episode 11, and welcome to Stuart Douglas today. Hello, Stuart. How are you doing?
I'm good.
Perfect. Thanks for taking the time. Who are you? What are you doing? Just introduce yourself a bit to the audience, please.
So my name is Stuart Douglas, and I work on WildFly and Undertow at Red Hat. So WildFly is our application server. It used to be known as the JBoss application server, but we changed the name, well, a little while ago now. And Undertow is the new web server in WildFly. So I lead the Undertow project, and I've also worked on other areas in WildFly, such as EJB, and just other EE related areas.
And since when are you doing that? I mean, that's typically,
I joined about 4 years ago.
oh, perfect. But that was not your start of your programming career, wasn't it?
No, before that, I was working for a company developing financial planning software, and I started out writing software that used the JBoss application server and used JBoss Seam, and then I started contributing a little bit of stuff back to Seam, and then I started contributing to Weld, which is Red Hat's CDI implementation, and then Pete Muir, who was in charge of Weld, sort of got in contact with me and asked if I was looking for a job, and I said yes, and I ended up working on the JBoss application server 7 team back when it was just starting out.
Okay. And your current role is actually the lead of Undertow, is that correct?
Yes, so like Undertow is our new web server. So it's a small, lightweight, embeddable web server that supports Servlet 3.1, and it's going to support a lot of the neat features that we're going to see in WildFly9. So it should support HTTP2, Speedy. It can also be used as a reverse proxy, which I'll demonstrate later. So you can actually use Wildfly as a load balancer against other Wildfly instances.
Okay, and
So
that's exactly the stuff you're working on right now. I mean, WildFly9 is in the making, if I'm not totally wrong, correct?
yeah, so we released 8.2 earlier or late last year, and now
Yep.
we're full steam ahead on Wildfire 9.
Do you have any idea when we see a first release of any kind to play around with?
We've already had an Alpha 1 release. Unfortunately, the stuff I'm going to show you today didn't make it into that release. So hopefully it won't be too long till we see either an Alpha 2 or a Beta 1, but I can't give you an exact date, unfortunately.
Sure, no problem. To show me the important stuff, I mean, I'm pretty excited. Let's go ahead.
Okay, so what I'm going to show you is I'm going to use Wildfire domain mode to set up three different servers. I'm going to have two backend servers and a front-end server that does the load balancing between them. And this front-end server is going to use mod cluster on the front end. So it'll automatically detect the two backend servers and then start load balancing between them. And so Wildfire domain mode lets you manage all these servers from the one place. So you manage both the load balancer and the backend servers just through the one CLI.
Okay.
So I better share my screen.
Yeah, that's a good thing.
There we go. So to start with, I'm going to start the server. So because I'm going to use domain mode for this example, I run domain.sh. And because I'm using clustering, I need to bind it to a real IP address. I can't bind it to localhost. So I'm setting the JBoss bind address to my local IP. So then lots of log messages, and we can see that Wildfire has started up. So with domain mode, the first thing I'm going to do is connect using the CLI, which lets me manage the server. So, and this just shows that I'm connected to a domain mode instance. And I prepared all the commands I need earlier. And the first thing I need to do is just stop all the existing servers because we don't need to use them. So when you start with domain mode just on a standard Wildfly instance, it'll start two servers for you in two different server groups. So I'm just going to remove these and create our own just for the purposes of this example. So these commands here, they're just remove commands for the existing servers. Now, the first thing I need to do is, because I'm using just binding it to a local IP address, I need to add that to the virtual host. Otherwise, mod cluster won't work correctly. So this command here, it looks long and complicated, but basically it just sets the alias on the virtual host to my local IP.
That's all blazing fast. I love the command line.
Yeah, so now we're going to add a server group for our backend servers. So we're just using the high availability profile, so it will support clustering, and we need to use the HA socket group for that, just because they go together. But now I need to add some servers to that server group. So I'm adding 2 servers, backend 1 and backend 2. And I'm giving the first one a port offset of 100 and the second one a port offset of 200. So by default, WildFly will bind to port 8080, but these servers will bind to 8180 and 8280. Now I'm going to start the servers. So this just tells the backend server group to start all servers in the group. So that will start both of them. And if we look in our log here, we can see the servers starting. So they look like they've started. So now, in order to actually demonstrate what we're doing here, I'm going to add a system property to each server that just gives it the server name. Otherwise, you can't really see that it's load balancing between the servers because the output will be the same. So this is just a system property called server name, and I'm just setting it to backend 1 for the first server and backend 2 for the second one. Now, I've created a simple deployment just to demonstrate this stuff. So it's a very basic deployment. It's only got 1 servlet in it. And by default, all it'll do is write server and then that system property, server.name. Now, if I also pass in the stateful parameter, it'll create a session and start counting sessions. So it'll just store a count attribute in the session and then write out how many requests have been made. There is also, in the web.xml, I've made it distributable so that if you do create the session will be distributed between the 2 backend nodes. So now I'll actually deploy that deployment to the servers. I've already compiled it and it's just sitting on my hard drive in the load balancing demo folder. So I'll run this command. So now we should be able, if you look in the console here, you can see that it's deployed on both servers. Now, if I go to a browser and go to 80,100, I should see the first server. So that's the first backend. Then 8,280 is backend 2. So now we've got our 2 backend servers up. Now we just need a load balancer to distribute the load between them. So our load balancer is using the default profile in domain mode. And so to turn it into a load balancer, I need to add the mod cluster filter to the Undertow subsystem. So this first command here will just create the mod cluster filter. It'll tell it to use HTTP socket for management. And it'll also tell it to use this advertise multicast mod cluster socket, which we'll set up in the next command. So we create that. And we create the mod cluster socket binding, just telling it the multicast address to use. And we also need to actually tell Undertow where to use that filter. So we need to just run this command to tell it to bind the filter to the default host. So the way this mod cluster filter works is that when a request comes in, mod cluster will look at the host and the context path and see if it knows of a deployment in the backend that will service that request. And if so, it will send that request off to whatever backend it deems most appropriate. If it doesn't know how to handle it, it'll just let it go through to the server. So you can have this server actually serving both servlet deployments or any other deployments, as well as acting as a load balancer. So now I need to actually add a server group for the load balancer, which I've just called load balancer. Then I add the server itself, and I'll start the server. So this is basically the same command as we ran for the backend servers, just a different profile and a different server group.
And speaking of servers and setup, this is actually the third instance running in that demo, right?
Yeah, so this is the third instance, which I've called load balancer, and we can see it's just started. So in this output, in the domain mode, it actually tells you at the start of the line what instance is running. So now that output that just appeared there was mod cluster picking up the two backend servers. So we can see here it's picked up the connection to backend 1 and registered our clustering demo deployment, and picked up backend 2 and also registered the clustering demo deployment. So with mod cluster, it advertises itself on the network about every 5 seconds, so it can take a few seconds for that to be picked up. So because I didn't specify a port offset for this one, it's just bound to 8080. And this request has got backend 2, then backend 1, backend 2 again. So as you can see, it's just load balancing between the two backend servers.
What is the default load balancing mechanism used by mod cluster?
It will do, I think it does round robin by default, but it also, the servers can send metrics back to mod cluster to tell them how much load they're under. So it will actually use that load information to determine where to send the requests. It also supports sticky sessions, which I'll demonstrate in a moment. So if you've created a session on one server, it'll tend to just send, it will send subsequent requests back to that same server. So now I've got 2 servers. We can add a third one. Same command again, just with a different socket offset. So that adds backend 3. Now we'll start the server. So backend 3 is up. And now we need to add that system property so that it's got a name. Now, hopefully, yeah, so now backend 3 has been added to the pool of servers, and it's load balancing between all 3. So now, in that deployment I showed you before, if I pass a stateful request parameter, it'll create a session. And so then, once that happens, all subsequent requests should go to the same server because it supports sticky sessions. So I'll just add the stateful request parameter, and now it's displaying the request count. And now it's been stuck to backend 2. So it'll just keep handling those requests. And because this is in an HA profile, we've also got high availability enabled for the sessions, so they'll be replicated to another node. So if I actually shut down server 2, so now it's being served by backend 3, but you'll notice that the request count hasn't been lost because the session actually failed over to backend 3.
Cool. That's what high availability is all about, right?
Yeah.
how do the session information wander from one server to the other?
You mean how there's
How is the
InfiniSpan is
replication mechanism implemented under the hood?
that's done using InfiniSpan,
Ah, okay.
which so yeah, I don't work too much on how the internals of the clustering backend, but InfiniSpan just uses multicast to discover all the nodes and build a cluster, and then there'd be some log message
Okay.
here is here. So
And Undertow is actually doing the work on the front end side, right? So
yeah,
dispatching
so
requests.
Undertow actually has its own implementation of the mod cluster front end, as well as having sort of the back end. And Undertow just works as a reverse proxy using non-blocking I/O, so you're not using up sort of threads or blocking threads doing this load balancing. And just as requests come in, it'll determine which server they need to be sent to and just send them off, and then just use non-blocking I/O to send the request to the backend server and get the response and send it off to the client.
So it's basically blazing fast, and it's just a coincidence that mod cluster is comparably close to the name of the famous Apache HTTP library, right? Or let's
No,
say
it's
one of
not.
them.
It's not a coincidence at all. It's actually basically the same code,
Okay.
because the so Jean Frederic, who's one of the main guys for Mod Cluster, he actually ported it to Java, and that's what we're using in Undertow. So a lot of the code is well fairly similar.
Okay.
So it should basically act the same as Apache running Mod Cluster. It's yeah, it should just hopefully be faster.
Yeah, looks like. I mean, it was quite an impressive demo, at least from a configuration perspective. Setting up Apache HTTPD and doing all the configuration in there is yeah, kind of awful and lengthy. And if you haven't done that before, um, it's just yeah awful, right? So having the chance to use the same command line interface, like configuring the WildFly instances, is yeah, let's call it a big plus, right?
Yeah. So I've actually put all the commands I used today up in my GitHub repository. So if you want to play around with clustering, you can basically just put all these commands into a domain mode CLI to a domain mode CLI, and you'll end up with a fully working cluster with a load balancer and two backend nodes. And you can just deploy whatever you want to that and start playing around with it.
That's totally convenient, and I'll make sure that I'll publish the URL to the gist accordingly. So, um, thanks. That was really, really cool. That was a great demo, and actually, I have to admit it was the first time ever that I've seen that setup being so blazing fast. So, as I said, I've been playing around with HTTP myself a bunch in my past, and Undertow makes that really easy, right?
Yeah, well, that's basically what we're going for, is just to make it really easy to configure, and then you only have WildFly instances. You don't have sort of don't need different versions of HTTPD or anything. It's just WildFly front and back.
Okay, let me ask one fancy question. What about load balancing WebSocket requests?
So Undertow, it supports WebSockets, but it will just pick one backend and send them off to that one backend. It won't try and sort of split up the messages on a single connection and send them off to different backends. But if there's demand for that, it could definitely be implemented, because it speaks. Undertow is also a WebSocket implementation. It sort of understands the protocol. It's just that I think that most applications won't sort of expect their WebSocket messages to be fanned out between backends. They'll expect just one connection to just go to a single backend. So yeah, it does support them. It's just that it doesn't load balance the messages. It just picks a backend to handle the connection.
Okay, cool, fair. Um, Another question: if you could pick the, let's say, three big ticket features in Undertow with the upcoming WildFly9 release, what would that be in your opinion?
Well, number one would be the reverse proxy, which I just demonstrated.
Yeah.
So number two would probably be the HTTP upgrade capabilities that we get in WildFly. So now, because we're using Undertow, we can actually multiplex everything over the HTTP socket. So EJB requests, JMS, even management, they all just run over the HTTP port now using HTTP upgrade, which is similar to basically the same as what you use in a WebSocket handshake. So instead of having a separate port for EJB, a separate port for JMS, now we only have one. The third one, I would probably say the WebSocket support, which is another big feature of Undertow, is it fully supports the Java API for WebSockets.
Okay, perfect. Stuart, thanks again for your time. It was a pleasure looking at what you did. So make sure to send me the links that I can publish everything along for our viewers later on. It was a pleasure talking to you. I hope we get a chance to meet when WildFly9 is finally GA or whatever, and talk a little bit more about all the features that we didn't were able to showcase today. So again, thanks for being here, being my guest, and have a great day.
Okay, thanks.